Hello, welcome to this video series on MDX for SQL developers. I'm Nasir Ali Mirza at DoSQLBI.com. In this video, we'll cover the remaining items that includes what is a set, what is access, hierarchy, level, and measures dimension. Now that we have seen what is a tuple, let's talk about what is a set. Set is a container of tuples. So in the examples that we have seen, whatever is contained within these curly brackets, it is a set. One set, each access contains a set. If I have a MDX statement that has one or more accesses, each access will be containing a set, whether an empty set or a set with one or more tuples. So in this statement, I have access 0 containing one tuple, and that tuple itself has one attribute. Then on access 1, I have a set that comprises of one tuple. In this example, we see on access 0, we have a set that is containing one tuple. Because my tuple is using only one attribute, I can remove these tuple identifiers. So if I run this statement, it's giving me the output of a set which is using one tuple having one attribute. I can also open and closing bracket and run the same thing again. I still see the same output. I could delete it only because this tuple had only one attribute. Had there been more than one attribute, then I had to necessarily add these tuple identifiers. Similarly, on an access, if there is only one tuple, whether of one attribute or more than one attribute, but if it is only one, I can delete this curly brackets, which is sort of a set identifier. So if I run the same query again, I see the same output. Had there been more than one tuples on this axis, then adding the curly brackets was must. Let's talk about the access that we have in MDX statement. When you write SQL queries, you don't have anything like access. The reason being, SQL queries produce a result set that are confined to two axes only, that is rows and columns. But when it comes to MDX, that only two axes rows and column restriction is not there. So the MDX statement that you see right now is producing the result, is making use of multiple axes. Now if I try to run this query within my SQL Management Studio, I will get that results cannot be displayed for cell set with more than two axes. There is nothing wrong with the MDX statement itself, but the SQL Management Studio, this itself cannot support showing results which are on more than two axes. I have here my SSRS report opened. This report is based on a query that is the same query basically. It uses axis 0, 1, 2, 3, and I'm going to run this query in the query designer of SSRS reports. Now this designer is able to understand more than two axes, and it's giving me a preview of this report. To see it further, I can preview this report. Here you see the result set, this SSRS report, which is based on an MDX query that is making use of more than two axes. I can drill down, I can see the further results. So we saw what is a tuple, what's a tuple set, what is set, and what is access, and how this is different from writing a SQL queries, and what are the limitations of a SQL Server Management Studio as of now to showing the results of an MDX queries that are based on more than one axis. And we saw the same result set coming up successfully in the SSRS reports query designer and the report itself. Next we will see what do we mean by hierarchy and level. Let me switch to SQL Management Studio again. Let's take a look at a geography dimension. So we said earlier, dimension contains attribute hierarchies or user-defined hierarchies. So in a geography dimension that we see, city, country, postal code, state, province, they are attribute hierarchies. And we then have a geography which is a user-defined hierarchy. User-defined hierarchies are created out of the attributes of the dimension. So if I see this user-defined hierarchy, it has country here, state, province, city and postal code, which is essentially using the attributes dimension in some meaningful order. Now if you see, this user-defined hierarchy goes from country, and then the next it has state, province, city and postal code. Attributes put under a user-defined hierarchy makes the levels. So in the geography user-defined hierarchy, we have country as a level, a topmost level. Then under that is state, province, and then city, and at the bottom of that hierarchy is the postal code. In the SQL statements, if we have to achieve the benefits of a user-defined hierarchy, we will normally use a group by clause. We don't have anything equivalent to defining them as part of the dimension design. It's important to note each of the attribute in a dimension is essentially a hierarchy as well. But these attributes are single level hierarchies. So the city attribute has only one level in it, the name city. Similarly, country has only one level, which is the country itself. There are many functions in MDX language that you can use against a level, not the attribute. So those functions can be used for the levels, not for the attributes. So what do we create these user-defined hierarchies? Benefit of that is what in SQL analysis services is called as aggregations. When we run a SQL statement with group by, it at the runtime would aggregate the values and then show us. Analysis services, one of the core benefits is it pre-calculates those values and keeps them ready for use. So when you run a query, readily provides you those results. It doesn't have to calculate it at the runtime. So when we define user-defined hierarchies and we arrange the levels, we arrange those attributes in a particular order, so I get pre-calculated values. We'll see some examples. I have already some queries written. I'm bringing them here. Let's see the first one. This first MDX query here makes use of a geography user-defined hierarchy, and under that it refers the country level. So basically that is this. Now let me run this query. What do I get as an output? I get a list of countries. Just note here, I haven't mentioned anything like children or members. But this country here is basically this level. It is not this attribute. When we refer to a level in an MDX query, by default, it returns all the members of that level. If I have to do same, if I refer country attribute, I will have to put .children to get a result set which will have all the members of that attribute. In this next query, I am referring again to the country level, but not in the user-defined hierarchy. I am referring country level here, which is part of the attribute hierarchy. So let's run this query as well. I get by default the same result. I haven't mentioned any children or member, but because this is a level, by default it will return all the members of that level. Let's go next. I now ran the country attribute, so that is this. Without any children or member, what did it return is a default member that's added by the system, all geographies. Now here, if I want to be able to see all of them, if I say children, then all will not be included. If I say members, then all will be included. Let's run this query again. Now I am getting the result set which is all the data members of an country attribute. The next one, I am referring to the root of the user-defined hierarchy, which is this geography.geography. Let's run it first without children. Let's see what it shows. It's showing me this is the root of the hierarchy. Okay, so the root of the hierarchy, as expected, whether user-defined or attribute hierarchy, is returning me the only member, that is system added all member. Now, if I put children to that, let's see what it returns now. So it is returning me the list of countries, which is all the data members of that particular root or attribute. I said levels and hierarchies, they enable us to use certain MDX language features. Let's see a simple example of that. In this example, I use something called as parent. Parent of what? That is this. In the geography user-defined hierarchy, I am referring to a state, province level, and in that I am directly referring to Texas by the key name. And then I am just saying I don't want to see that itself, but I want to see the parent of that. So parent of state province Texas would be United States. Similarly, there is another province with the name Quebec. I'm just saying show me the parent of that Quebec. Parent here for state province, parent would be country. For city, parent would be state province. For city, maybe grandparent would be country. These things, I can use these features of the MDX language when I'm using the levels and hierarchies. Let's run this statement and then see what we get as an output. For Texas parent, it's showing me United States, and for Quebec's parent, it's showing me Canada. So we saw what is a hierarchy, what are its benefits, what's its use, and what are levels within user-defined hierarchies or attribute hierarchies. Now we'll take a look at the last item in this video, that is measures dimension. After looking at what is a hierarchy and level, we'll see the last item in this video, what is measures dimension. Let me switch to SQL Management Studio. Measures is like other dimensions in the analysis services database with some differences. Measures dimension contains the major groups which we covered in the earlier video. These measures are basically the facts in the transaction tables which can be grouped under various folder views. Measures dimension has only one attribute in it. So all of its members share the same hierarchy. If I compare measures dimension, say, with the geography dimension, there are multiple attributes in this dimension or other dimensions. Each one has its own hierarchy. So I can say in a geography dimension there are multiple hierarchies in that. But when it comes to measures dimension, it has only a single hierarchy and all its members belong to that hierarchy. Let us see some examples. I have some queries already written. The first one, you see only the dimension name as measures. Let's run this query. What we see is there are, among all its various members in a dimension, it is returning me reseller sales amount, which is this. This particular member of a measures dimension has been defined at the design time as a default member. That's why even when I am not referring to any particular member of a measures dimension, it is returning me this particular member. Now I'll run another query which is referring to the members of the measures dimension. Let's see what we get. We get a list of all the facts that are there in the measures dimension, across all the major groups. So which means it is listing all the majors, be it in any of the major groups. So all of them are members of a major, of the majors dimension. The next one, I'm referring to a particular member, which is internet sales amount. So I get that as the output. One difference I wanted to show here is we could run a query like this where I'm referring to the majors dimension name without any member, and I'm still getting a default member of that majors dimension. If I try to do same for the geography dimension, let us say, I'm just saying the dimension name, I'm not referring to any particular member, and I run this query. I'm getting the error message that geography dimension contains more than one hierarchy. Therefore, the hierarchy must be explicitly specified. So because majors dimension is a single hierarchy dimension, even when I am not referring any particular hierarchy here, it is still showing me the results because there is only single hierarchy, so it takes it out of context. Now in this case, which is a geography dimension, there are various hierarchies like city, state, postal code, state, province. I cannot get a result because can't define a default hierarchy for a dimension. Now if I specify a particular hierarchy as we saw previously, I can get an output of that. So that is the aspect how majors dimension is different from other dimensions. This concludes our session on MDX terminology, where we spoke about all different terms and concepts that will form as a base for our next video in this series. In the following video, we will see what are MDX language rules.